Do I need to reset this? Probably.
Don't worry, you can start.
All right, so to start with, I need to skip quite a few slides because I thought I had a long presentation, but it turned out I only had 7 minutes. So I'm trying to go speed it up a little bit. Some of the stuff that is on the slides, you can use it as a reference for this. But mainly the question is, do we need OVS-DPDK to be more deterministic? And the reason why I'm asking that question is because we see some OVS-DPDK users raising questions that they really would like to have a more granular spread latency, or basically they want a smaller maximum latency for their system. And what also changed is that they are actually willing to pay for it, meaning they are okay to dedicate CPU resources for it. The only thing is that I've seen people ask for it, but I have not seen any proof that it's really an issue. I've seen it being an issue when there was bugs in OVS that was causing the long latency. So the one question I have, and it's at my conclusion, but I do it now in case I miss some of the slides, is that I really would like to see some proof of this, or people that have experience with it, and if they have numbers to share, that would really be nice. I have some tooling around it, which I share on some of the slides that might be useful. But in general, what is causing this unpredictability in the latency? So what I've seen is that the main reason for this unpredictability is the Linux system calls, because the kernel goes off, does some stuff, and then comes back. But in that meantime, the PMD threads are not able to do any of the data processing, so you have a stall there. So what I've done, I wrote a small script based on perf output that will give us some data based on the syscalls. How long are they taking? They do it based on the backtrace, so you can actually see which part of the code is calling causing the delay. So that's what I have. But just to give it away what it is, what we've seen a lot of syscalls is OVS going to quiescent state in the PMD thread. And we see a lot of system calls in vhost environment where it's driven by a kernel on the virtual machine rather than in DPDK applications. And one of the main things that is, at least shows the best benefit, is the write to kernel interfaces. So if someone has a kernel interface still attached to a DPDK bridge or a NetDev bridge, we see that it takes quite some time for them to get processed and get on. Other things we've seen was some writing log files, but those you can at least mitigate by disabling the logging for debugging. And we also saw some logs in the bonding code that sometimes pop up. But I'm trying to concentrate on the first 3 of them. So this is the slides I'm going to quickly skip. It has a reference where you can find the perf script, how to run it, and it has some of the outputs, which I'm quickly going through just to save some time on it. So some of the histograms and the backtraces. So what did I change on the OVS infrastructure to make this happen? So first of all, what I introduced was something called an assist thread. It's basically another PMD, but the only job of that thread is to handle tasks that need to be overflown and cannot be done by the PMD thread. So it's based on the multi-producer HTS hash tail sync queue that is available in DPDK. So it's a multi-producer, so every PMD can just basically take some data and push it onto the queue, and then the assist thread will take it off and process it. It has the same configuration interface as the PMD CPU mask, so you can have you can have a set of assist threads if you want, but it's bound per NUMA node, so all the traffic from NUMA A will go to NUMA A and B to B. If you only decide to do a single, all the traffic from all the PMDs will go there. Some other thing, because I was really interested in what the performance and benefits would be, there is tons of stats that I've added to this. So it's in the existing command, but you get some stats on number of messages sent for which specific data sets. If you have failures because the ring is full, all that kind of stuff. For the assist thread, it's basically the same. You can see cycles per message that it takes, stuff like that, just to get an idea if the CPU resources are used nice or not. It also has some histograms on how many times you pull the queue and it's empty, or how many messages are in the queue, stuff that you can use to do troubleshooting when you're trying to experiment with this. Okay, so the first thing I tried to fix was the quiescent state. And that basically is PMDs will call every 1024 iterations or every 10 milliseconds, whatever comes first. It will call this call, and there's two major things that it does. It tries to lock a mutex. If it gets the mutex, you might get the mutex system call because you have some stuff that needs to be done on it. And then it will try to do a write system call because you're changing some sequence numbers through the latch interface. So what I've done, I don't want to go in details to save some time, but I split it up into two phases. So the first phase, it only does the sequential read and update some thread-specific data. And then it will send a message on the ring asking the assist thread to do the actual flushing of the callback set and changing the sequence number, which requires the log. So what does it do? Other than removing the system calls from my trace, it did not really do any performance increase or decrease, at least that I couldn't measure. Maybe I need to, build a more specific task that does a lot of stuff in between, but I think that the timing was so short that it didn't really give any of the benefits that I would hope it would give. So the latency stayed roughly the same, at least the max latency stays roughly the same. The second thing I tried was the vhost interrupt. So for people who don't really know how that works, is that the vhost interface will put the data into the ring buffer, but then it needs to inform the kernel, for example, running on the virtual machine, that there is traffic or data ready. And what it will do, it will the DPDK interface will put an event FD write system call on it so that it will wake up the kernel thread on the other side. This is not a problem if you have a DPDK application running in your virtual machine, because that will constantly pull the ring buffer and there will be no extra overhead. So what I've done, I slightly modified DPDK to give me a callback when a kick needs to be sent, and then I can determine are assist threads available. If so, I will send a message to the assist thread to do it. That's all. So you don't call the system call. So the data was somewhat interesting in this case. So what I've done is I'm running a zero loss test from a physical port to a physical port. And then on top of that, I'll send a very simple ping -f traffic. So go as fast as you can, sending that traffic to the bridge, to the vhost interface. And then the things I saw is that the maximum latency was decreased very little, only 0.7% on the total. But I think that's 0.7% represents about almost 8K of packets on a 100 gig link. So it is sort of significant. But I think we can even increase it a little bit more if there is more vhost traffic, because if there's more vhost traffic, there is probably more kickbacks that you can reserve with messages. The only thing that was a bit odd that I saw is that my performance rate was going down from roughly ping sending 70K packets a second to 56K packets per second. And I think it's based on the behavior. Of course, what it does, it sends a number of packets and then waits for a response and then sends the next batch, or at least has a sliding window of sending it. I tried some iPerf statistics just to see the same results, but iPerf for both UDP or TCP did not see any of the latency increase. But just to be sure what's going on, I did some tests, and then what I noticed is that on the PMD thread, there was an improvement of about 1,000, a little bit less than 1,000 nanoseconds when doing this event kick or skipping this event write. But on the other hand, I see almost a 2,000 nanosecond additional latency for the packets being sent through the vhost interface before it actually is received by the vhost interface. So that's one part. The other thing was the OVS kernel interface transmits. I think this is the biggest change, not the biggest change, but the biggest best result. In this scenario, we see that I replaced the send message and the write message by just taking the entire batch of packets that need to be sent to a Linux interface. I just send that data over the message bus and then have the assist thread do it. So there, it was a bit surprising to see. So I did a similar approach. So I figured out what the maximum the maximum throughput would be without losing any packets by the PMD. and then I would send 97% of that point-to-point traffic, port-to-port traffic, and then about 3% of bridge traffic going into a bridge interface, which is a Linux type interface. And then what I saw is that the average latency was already going down by, like, was it 0.2 million? 0.2 microseconds, which is pretty large. I think that's about 1.5 million packets in the delay. And then also the latency for those packets were also reduced by about 74,000 nanoseconds. So that was like a big difference. I didn't expect that to happen there, especially the average latency. But on the other hand, when I just sent a limited number of packets to the kernel, let's say 10,000 packets per second, I did not see that any impact on it. So the question, I think, is really, like we said, if you probably have a lot of packets going to Linux type devices, you might probably not have dimensioned your network correctly. You might want to, you might not see this latency gains because you don't really have that much traffic going to it. Anyway, I'm already over time. It looks like it's, let me quickly wrap up the conclusion. So my conclusion here was that, for the RCU recent state, I have not really figured out if it's anything beneficial at all. I might just need some more tests, but I think I can say that it's not really that beneficial. The vHOT kicks, I did see some beneficial there. But we also have quite some latency added to the vhost traffic. So that might be a problem, if they're willing to pay that to get the more consistent latency. And I think the same thing goes for the kernel path. There might be a sweet spot where the latency versus number of packets going to the kernel might be the problem. Okay, and then the final spot, chat this slide. So we need to run some more tests to get that stuff sorted out, I guess. But the question remains, like I already said in the beginning, is this a real problem? Are we seeing this in the field, and people really think that they have a problem? If they think they have a problem, it would be really nice if we can get some statistics or some data insights, maybe by running the Perl script and just getting the raw data, so that we can see, are we really trying to address the issues that we see here, or is it maybe some other system call that is causing the delay in the system? That's all I have. So the code, the work in progress code, is available on my GitHub if you ever want to try and play with it. But that's it. Thank you for listening.
All right.
That's all, folks. Thank you so much. All right. Do we have any questions in the room for Eelco? Again, we have about 30-second delay on virtual, so we have one here. Again, if you're virtual, please go ahead and ask questions. Thank you.
Do you think it would be worthwhile to rerun the same test or similar tests with some sort of fixed background load on the system to sort of simulate an overloaded Linux server with a lot of distraction operations that may trigger that sort of like increased latency in syscalls?
Yeah, I think that's a very interesting part to see if that is an option. The only problem I'm struggling with is, how would you define the load so that it's repeatable in the thing? But yeah, definitely, if there is more load on the system, it will definitely increase it.
All right, any more questions in the room? Yeah, if not, I have not seen. We have some stuff in the chat.
No, that's just me ignoring.
Oh, okay. I guess we don't have any questions virtually.